All right, factoring is the one that we're looking at today. It says students are going to review the characteristics of expressions and factors. They will also determine a process to use when they are factoring their polynomials. That's what you guys are going to be doing for me today. What process do we use? Very different processes depending on what the polynomial looks like. All right, but before we do that, let's cover some basics here. Some things that hopefully you remember back from middle school. First thing, A, says what numbers are factors of 24?
6.
6 is a factor of 24. What else?
8.
8. 12. 2. 3. So all these numbers you're calling out are factors of 24. Why are they factors of 24? All right, we can divide that 24 by all these numbers you're calling out. So I want you to write those down for me. We got a 1, a 2, 3, 4, 6, 8, 12, 24. All of these numbers are factors of 24. They're all factors of 24. Now part B over there says we're going to write down the prime factors of 72. Now, before we do that, anybody remember what a prime number is? What's a prime number? So can you give me an example of a prime number? 11 is an example. 13 is an example. 7 is an example. 3, 5. So what exactly is a prime number? All these numbers you're calling out.
I have no idea. I just remember them from
They are prime numbers. What are they?
by themselves.
There we go. Now we'll get somewhere. A prime number is a number that's divisible only by itself and 1. Okay, so in this particular case, we're looking for the prime factors of 72. Okay, so here they are.
Oh, is that when they do the U-shaped thing? Remember, like, they put, like, 72 and then they put 72 in.
There you go. The factor tree.
Yeah.
I think that's what you're talking about.
Oh,
Yeah. All right, so this right here would be the prime factors. In other words, if I were to multiply a 2 times a 2 times a 2 times a 3 times a 3, all that multiplied together would give me a 72. Notice all these numbers I have written down are prime numbers. 2 is a prime number, and 3 is a prime number. But rather than writing it as 2 times 2 times 2 times 3 times 3, we can also write it as 2 cubed and 3 squared. It's the same thing. They say exactly the same thing. So these would be the prime factors of the 72. Now that last part over there, C, says we have the fraction 36 over 48, and they want us to simplify that fraction using the greatest common factor. In other words, reduce it. How do you reduce it? What did y'all do in elementary to reduce, not elementary, but middle school, to reduce these fractions?
You wrote out, like, all there. Is that where you wrote out all of the...
That would be one way. That's like kind of like over here, writing out all the prime factors and canceling them out. But once we get more comfortable, we can look at the greatest common factor. Call that the GCF, greatest common factor. So if we look at those two numbers, 36 and 48, the greatest common factor would be a 12. Both of those numbers are divisible by 12. 36 is divisible by 12, and 48 is divisible by 12. So that 36 can be written as 12 times 3. The 48 can be written as 12 times 4. And of course, when we cancel out these 12s, what are we left with? 3 over 4. That would be the reduced form. That's the simplified form. And we found that by using the greatest common factors. So down there at the bottom it says, what does it mean to factor a number? When we're factoring a number, what exactly does that mean? It means to find a number that multiplies to give you that number. In other words, if I were to give you the number 6, and I would ask you for the factors of 6. I'm asking you, what are some numbers we can multiply together to get 6? Well, 3 times 2, right? 3 times 2 are factors of 6. Are they the only ones? They're not the only ones. What else am I missing besides 3 times 2? 1 times 6. Okay, so these would also be factors. 1 times 6. So all of these are factors of the, they're numbers that multiply to give you that number back. All right, so that's just a little quick reminder of some stuff from middle school. And we're going to kind of tie that in with what we're doing today. Up here at the top, they give us a polynomial. This is kind of like your homework. Well, actually, this is just like your homework. This right here are two polynomials. And in order to do that, they did the FOIL method. And this is the answer we got. That was the answer, just like your homework. So it says here, consider the polynomial problem above. What are the factors? In other words, this thing right here. What are the factors? What did they multiply together to come up with this particular answer right there? What was it they multiplied? Well, it's this thing up here in the front. It's the 2x plus 3y and the 4x plus y. These are the factors. Those are the two things that were multiplied together. Those are the things you'll be looking for today, the factors. So down here at the bottom when it says, what does it mean to factor a polynomial? What we're going to be doing is we're going to be finding polynomials that we can multiply together to give that certain answer. Just like up here. The factors were 2x plus 3y and 4x plus y. Because those are the two things we multiply together to get that 8x squared plus 14xy plus 3y squared. So again, that's what you're going to be doing for me today, finding those factors. Question is, how do you do that? Well, it's going to depend. There's a couple of steps involved here, which we'll be looking at. So here's going to be step number one. Step number one says you're always going to look for terms, or look at the terms, and find the greatest common factor, GCF, greatest common factor. That is always going to be the first thing you do. So if you look at the first example, they give us 6x squared plus 14x. Anybody know what you call that? Is that a monomial, binomial, or trinomial? That's a binomial. So what we got to do is we got to find the greatest common factor for that binomial. So we're going to start with the coefficients. We're going to start with the 6 and the 14. What I want to know is what is the greatest common factor? In other words, what's the biggest thing I can divide a 6 and a 14 by? What goes into 6 and 14? 2. There you go. You're right. 2. 2 will go into 6. 2 will also go into 14 even. Matter of fact, it's the biggest thing that will go into 6 and 14. But if you look closely, there's something else that these two terms have in common. What else do you notice that they both have in it? They both have an x in it. All right, so we're also going to include that as part of our GCF, our greatest common factor. So what I'm going to do is I'm going to call the GCF 2x. It's the largest thing that goes in a 6x squared and a 14x. So that's going to go outside my parentheses. That's one of the factors. You're halfway there. What we need to do is find the other factor. What goes in the parentheses over here? Here's how we're going to do that. This 2x, I need to multiply it by something to get this 6x squared. Question is, what is it? 2x times a what will give me 6x squared? 3x, you got it. 3x. And we can check that. 2x times 3x is 6x squared. Well, we're missing one other little thing here. Now we need to figure out what goes over there. So this 2x times a what will give us back this 14x. What can I multiply by? 7. Notice we don't need an x this time though. That 2x times that 7 will give us a 14x. These are what we call the factors. Those two things, when you multiply them together, will give you that 6x squared plus 14x. Again, that's what you guys are going to be doing for me today. Now notice that is step number 1. So there is more involved, but for right now, we're going to leave it at that. The next example, we have this 4a squared b plus 6ab squared minus 10ab. And again, we're looking for the GCF, greatest common factor. Now notice this time there are 3 terms. And what do you call it when there's 3 terms, Samantha? Trinomial. All right, so we're going to find a greatest common factor for this trinomial. So I'm looking for something that will go into all 3 terms. So if I look at the 4, the 6, and the 10, what's the biggest number that will go into a 4, a 6, and a 10? 2. Let's put that down. That's going to be part of our GCF. But if you look closely, all 3 of those terms have a certain letter in them. What do you notice?
A and B.
They have an A, and they all have a B. So that's also going to be part of our GCF, 2AB. That right there is what's going to go outside the parentheses, the GCF. So you have found one of your factors. Now you got to figure out what goes in the parentheses. So it's going to look just like that first example. What goes in this one here? Well, what do I need to multiply the 2AB by to get a 4A squared B? A 2, definitely a 2, because 2 times 2 is going to give me the 4. But I need an A squared. So I'm going to need another A here. Because an A times another A will give me that A squared. Of course, that B is already taken care of. It's out here in the GCF. All right, let's keep going. Now I need to figure out what's going to go in that. 2AB times a what will give me this 6AB squared. What do I need to multiply by? 3 for sure. Anything else? We're also going to need a B. Because a B times another B is going to give me that B squared. Notice no A though. Okay, we got to go one more time here. Need to figure out what this last term is. What do I need to multiply by to get a negative 10AB? 5. Close. Not 5, but a negative 5. Because 2 times a negative 5 would give me a negative 10. By the way, do I need a variable? Do I need a letter? No. The A and the B are both already taken care of outside in the GCF. So, these are what we call the factors. Those are the factors. When you multiply those two things together, this is the answer you're going to get. Now, on the notes, they only gave us 2 examples, and I feel that's not going to be enough for you to feel comfortable on your homework assignment today. So, what I want you to do is get out some scratch paper, because I'm going to give you a couple more examples. If I just give you those 2, I have a feeling it's not going to be too correct. So, get out some extra paper. We're going to do some more examples. More examples. All right, here's another 3 examples of that GCF again. We're still working with GCF. GCF stands for greatest common factor. Now, obviously, the bigger polynomial you have, the more work it is. The first one, though, not too big. We've got a binomial. Got 2 terms. So I want to know what the GCF is. So let's take a look. I've got a 7, but I also got a 49. What's the biggest thing that will go into a 7 and a 49? 7. That right there is my GCF. Notice there is no X, and that's because that 49 doesn't have an X on it. So 7 is it. That is your GCF. That's what's going to go outside the parentheses. Now we need to figure out what goes inside the parentheses. So let's see here. 7 times a what will give me the 7x. What do I need to multiply 7 with to get a 7x? An x. There you go. 7 times the x is going to give you this 7x right here. We also need to get this 49. So 7 times the what will get you that 49 then? 7. Positive 7 or minus 7? Positive 7. There it is. You just factor. Those 2 things multiplied together would give you this answer over here, 7x plus 49. That's it. Let's try the next one here. 2y plus 6xy. I'm looking for the GCF. Let's start with the big numbers, the coefficients. The 2 and the 6. What's the biggest number that goes into 2 and 6 even? 2. Let's see. Variables. Do they have any variables in common? Y. So that's going to be part of our GCF as well. 2y is our GCF. It's what goes outside the parentheses. Now we're going to have to figure out what goes inside the parentheses. Be careful on this one. 2y times a what will give you a 2y. 1. You got to have 1. 2 times 1 is 2. Not a 0, because if I put a 0, then I'd end up with none. I'd end up with 0. Do it one more time. 2y times a what will give you a 6xy. 3. But you're also going to need a x. Also need the x. Now notice you can always double check your work here. If I use distributive property, 2y times 1 gives me that 2y. 2y times the 3x gives me the 6xy. So you can always double check to make sure you're coming up with the right answer. Alright, so those are the factors. Number 3. This time we have 30x cubed y plus 35x squared y squared. Let's start with the big numbers, the coefficients. 30 and the 35. What's the biggest number that will go into a 30 and a 35? 5. But notice they both have what letters in them? X and a y. Now here's where it's a little bit tricky. Let's take a look at the x's real quick. Notice this first term has x cubed. The second one has x squared. What we're doing is we're looking for the GCF, the greatest common factor. We want the most that they have in common. So this one right here has an x to the third, which means x times x times x. This one right here is x squared, which means x times x. We want the most they have in common. What's the most amount of x they have in common? X squared. So we're going to factor out the x squared. They both have at least 2 x's in them. You'll see that, right? This one has 3, this one has 2. Matter of fact, we're going to do the same thing with the y. The y, there's a y on this one, and there's a y squared on this one. We want the most they have in common. Well, the most they have in common is just 1y, right? So 5x squared y is what we're going to call our GCF. Now I'll give you an easy way to remember that. When you have exponents on your variables, like I do with these x's here, we want the most they have in common. And the easiest way to figure out which is the most they have in common is just pick the one with the smaller exponent. So this had a 3, this had a 2. We're picking the one with the smaller exponent. Of course, we still got to figure out what goes inside the parentheses. So help me out with that part. 5x squared y times what will give me back this 30x cubed y. 6 for sure. And what else? X. Let's just double check that and make sure. 5x squared y times 6x gives me 30. An x squared times x is x cubed. And we still have the y. So that is correct. Now we got to get the last part over here. 5x squared y times what gives me the 35x squared y squared. 5 times what is 35, guys? 7. I've got the x squared part already. I need a y squared though. What am I going to need to put on that 7 to get a y squared? Another y. Y times y would give me a y squared. So these are my factors. When you multiply those two things together, that's the answer you're going to get right there. This is called GCF, greatest common factor. All right, I got a couple more for you, and then we'll move on to something different here. Next one, 20d squared e squared minus 8d to the 6 e to the 6. Still looking for that GCF. So let me see. I've got a 20, and I've also got an 8. I'm looking for the largest number that'll go into 20 and an 8 even. Think of it. 20 and an 8. 4. That is correct. 4 goes into 20, and 4 also goes into 8. Notice they both have a D in them. And I just told you we're always going to pick the one with the smaller exponent. So which one has the smaller exponent? D squared. Matter of fact, we're doing the same thing with the E. They both have E in it. So we're going to pick the one with the smaller exponent. That would be the E squared. That right there is what we call the GCF, greatest common factor. That is one of your factors. We got to figure out what goes inside the parentheses now. So, help me out. 4 times what will give me back that 20 right there? 5. Notice we've already got the d squared. That's taken care of. Same thing for the e squared. It's already taken care of. So I don't need any letters on the 5. Fine the way it is. Now I'm going to move on to the next thing. Negative 8 d to the 6 e to the 6. 4 times what will give me that negative 8 right there? Negative 2. But I need d to the 6th power. Right now all I have is d squared. So Olivia, help me out here. What do I need? D to the what power? Remember, when I get done, I should end up with d to the 6th. That is correct. A d squared times a d to the 4th would give you a d to the 6th power. Matter of fact, it's going to be the same thing for the e, right? E to the 4th power. Because when you multiply e squared times e to the 4th, you're going to get your e to the 6th power. So, these are what we call the factors. Those two things multiplied together would give us that thing right there. All right, last one, and then we're going to move on to something a little different. This one's a big one. This one has 4 terms in it. Alexander, what do you call them? There's 4 terms. Monomial, binomial, trinomial, or polynomial. Polynomial. That is what we have here is a polynomial. Now, since there are 4 terms, we got to make sure our GCF is in all 4 terms. Not just in 1 or 2 of them, but it's got to be in all 4 terms. So if I look at the coefficients, I've got a 2, I've got a negative 1, that's this one right here. I got a 5, and I also got a 1 here. So I'm looking for something that'll go into all 4 of those numbers. Anybody know what goes into all 4 of those numbers? 1. That's it. Just 1. Now I'm going to go ahead and put it for right now, but it's really not necessary. But just for right now so we can see it, I'm going to put it. 1 is the biggest thing that goes into 2, 1, 5, and 1. Do they have any letters, variables in common? Samantha, what letters do they have in common? Huh? Letters, variables. X and Y. Notice all of these have an X and a Y. But since they all have an X and they all have a Y, we got to pick the one with the smaller X one. That's the GCF, the greatest. So this X has X to the 3rd. This X has X squared. This X has X to the 1st power. And same thing with this one, X to the 1st power. So the smallest exponent would be just the X, which is what I already have here. Matter of fact, the same thing for the Y. I've got a Y squared, and a Y to the 3rd. Out of those 4, the smallest I have is a Y to the 1st. So 1xy is what I'm calling my GCF, greatest common factor. Now I need to figure out what goes inside the parentheses. So 1xy times what will give me that thing right there. What I need to put in there. Hello? Anybody out there? 2x squared. 2? Because 1 times 2 is going to give me the 2. But notice that's an x to the 3rd power. Right now all I have is an x. So I need an x squared. Don't need the y though. That y is already taken care of. So let me move on to the next thing, which is this right here. I need to end up with a negative 1x squared y. So here we go. I'm going to need a negative x. That's it. Because a 1 times a negative is a negative 1. An x times an x is an x squared. And the y is already taken care of. So that's all you need for that, a negative x. Now I want to get that 5xy squared. So what am I going to need in the parentheses? 5. What do I need next to that 5? A y. And y times y will give me the y squared. All right, we're down to the last term. I need a 1xy to the 3rd, and right now I have a 1xy. So I'm going to need over here a y squared. because that y times this y squared would give us the y to the third. So this right here would be the factors of this thing right there. Those are the factors. All right, so just a little extra practice. Like I said, if I just left you with those two examples, I don't think that would be good enough. So that takes care of GCS. Remember, that was step number 1. Now we're moving on to step number 2. Step number 2. Here. Now this is back in your notes, guys. Go back to your notes now. Back to your notes. It's at the very bottom of the page there. It says, after you check for that GCF, the remaining polynomial can be factored by several different methods according to the number of terms that you have. So if there's 2 terms, we're going to do one thing. If there's 3 terms, we're going to do something else. If there's 4 terms, we'll do something else. It all depends on how many terms we have. We're going to start by looking at what happens if you have 2 terms. That's what we're going to do first. 2 terms. All right, so we're going to look at something called the difference of squares. Difference of squares. Difference. What operation are they talking about when they say difference? Subtraction. Notice right here there is subtraction. Squares. Squares meaning a is squared and b is squared. Now it says here that a squared minus b squared is going to be equal to a plus b times a minus b. Now what does that mean? How does that work? Here's how it works. Here's our first example. 9x squared minus 64y squared. We want to factor that. What 2 things were multiplied together to get that as the answer? Well, first thing we're going to do is look for that GCF. That's what we just got through doing. If I gave you a 9 and a 64, and I asked you for the greatest common factor, what's the biggest thing that goes in a 9 and a 64 evenly? 9? Well, 9 goes into 9 for sure, but does 9 go into 64 evenly? No. Is there anything that goes into 9 and 64? 1. 1 is the biggest thing. 8? Well, 8, does that go into 9 evenly?
Oh, no.
Not even, right? Not even. So, in this particular case, guys, there is no GCF. This particular one, there is no GCF. At least nothing bigger than a 1. And that 1 is not going to help us out a whole lot. So we're going to have to come up with a different method. How do we do this? Well, that's where that difference of squares comes in. What this does, or what this says here, is we can find the factors using this thing right here. Here's how we're going to do it. We're going to take the first term, which is our 9x squared, and all we're going to do is we're going to take the square root of it. How do you take the square root of 9x squared? Well, anybody know what the square root of 9 is? 3. Square root of 9 is 3. Why is it 3? Because 3 times 3 is 9. What's the square root of x squared? X. Why is it x? Because when you multiply an x times another x, you're going to get a x squared. So what I just did is I took the square root of the 9x squared, which is a 3x. I'm going to do the same thing with that 64y squared. What's the square root of 64? 8. Why is it 8? Because 8 times 8 is 64. What is the square root of y squared? Y. Why? Because y times y is y squared. So that's the first thing you're going to do. You're going to take the square root of both the first term and the second term. That's going to be the hardest part about this. Because now what you're going to do is you're going to write this with a minus, but you're also going to write it with a plus. And there's 2 factors, and the factors are almost the same thing. The only difference between these 2 factors is one has a minus, the other has a plus. Okay? That is the only difference between these 2. If I were to do FOIL like we were doing yesterday, what's the answer I'm going to get if I do FOIL? You can get that thing right there. So remember, I told you we're working backwards now. This is the answer you got yesterday. Now you're turning around and giving me the 2 things that we multiplied together. Okay, so these are called the factors. Factors. Let's try that again. Next example here. 20x squared minus 45. 20x squared minus 45. Remember, the first thing we're always going to do is look for a GCF. Oh, this one has a GCF, and you said it's what? 5. Very good. You are correct. How about any variables? Are there a variable in both of the terms? No. So 5 is the GCF. What we do in the parentheses then? 5 times what would give me 20x squared? 4x squared. There you go. 5 times 4x squared is the 20x squared. How about 5 times what will give me that minus 45 over there? Negative 9. So that is the GCF. That's what we were just doing a minute ago. But we're not done. Because remember, this is step number 2. What we're going to do now is we're going to check this thing that's in parentheses, this part right here. And we're going to see if we can factor it some more, which in this case we can't. We're going to use this difference of squares again, exactly like we did example number 1 over here. So ignore the 5 for a minute. Just pretend that 5 is not there. We'll worry about it in a minute. And I want to factor 4x squared minus 9. I'm going to use that same little rule that I did over here. So here we go. 4x squared. What's the square root of 4x squared? 2x. Now I'm going to take the square root of the 9. The square root of the 9 is a 3. So all I've done is taken the square root of 4x squared, which was 2x, took the square root of 9, which was a 3. Now I'm ready to write the 2 factors. Ready? One of them is going to have a minus. The other is going to have a plus. Remember, they're almost identical. The only difference is one has a minus, the other has a plus sign. That's the only difference between these two. Those are the factors of 4x squared minus 9. However, keep in mind we factored out a 5 earlier. We can't just throw it away. So all we're going to do is that 5 that we factored out earlier, we're just going to bring it down. So these are my factors. This time I have 3 factors rather than just 2. 5 is one of the factors. 2x minus 3 is the second factor. And 2x plus 3 is the third factor. So this one has 3. And sometimes that happens. Sometimes you're going to have 3 factors. This is called difference of squares. It only works if it's subtraction in the middle, and only if we can take the square root of both of the terms. Difference of squares. Now again, guys, they only gave you 2 examples, and I feel if I leave it at that, it may not be good enough. So we're going to take a look at a couple more. So on that scratch sheet of paper you had pulled out earlier, let's try a couple more here. First one we got is x squared minus 49. First of all, notice there is no GCF. That's our first step. Look for GCF, which in this case there is none. So the next thing I'm going to try is that difference of squares. I see subtraction. Now I'm going to try and take the square root of these 2 terms. The square root of x squared would be a x. The square root of 49 would be a 7. That's the hardest part. So now all I'm going to do is write it twice. Once with a minus, then again with a plus. These are the factors of this thing right here. If I multiply those 2 things together, I'm going to get an x squared minus 49. That's it for difference of squares. Let's try that again. 2y squared minus 242. Remember, we're always going to start by looking for GCF first. Is there a GCF on this one? Is there something that goes into both a 2 and a 242 even? 2. 2 goes into both of these numbers even. So let's pull it out. That's the GCF. Do they have any variables in common in both terms? No. I have a y, but only in the first term, not in the second term. So 2 is the GCF. Let's figure out what goes in the parentheses now. 2 times what will give me 2y squared? Y squared. 2 times what will give me a negative 242. You don't know, put it in your calculator. 2 times what will give me a negative 242. Negative 121. Negative 121. Now what's going to happen is some of you are going to stop right there and say, all right, I'm done, that's the answer. Well, no. You always got to check what's in the parentheses. You may be able to factor this some more, which in this case we can. We can do that difference of squares. So if we ignore this 2 for a minute, I want to factor this. So just like we were doing up here, number 1, we're going to take the square root of y squared, which is a y. We're also going to take the square root of 121, which is, what is the square root of 121? 11. And remember, we said we're going to write it twice. One of them is going to have a minus. The other is going to have a plus. They're almost identical. The only difference being one has minus, the other has a plus. Don't throw that 2 away. It's still one of your factors. So just bring it down. And now we got it. Those 3 things right there are my factors. All 3 of us. All right, I want you to try that last one on your own. See if you can do that one by yourself. 4x squared minus 25. What are the factors? What 2 things can we multiply together to get 4x squared minus 25? What are the factors? Look for the GCF first. If there is no GCF, then we'll try that difference of squares. But you always want to try your GCF first. Greatest common factor. All right, Garrett, does this one have a GCF, greatest common factor? Yes. What was it? No, that's because there is no GCF. Now, we do have a 1, but 1 is not going to do us a whole lot of good. You are right, 1, but that doesn't do us a whole lot of good, okay? So, what we're going to try now is that difference of squares. So, let's see how you did on the difference of squares. You should have taken the square root of 4x squared. And what was the square root of 4x squared? 2x. Then you should have taken the square root of 25. The square root of 25 is 5. We're doing square root. Square root of 25 is 5. 5 times 5 is 25.
Oh, I did half of 25.
Oh, that's what it is.
I thought you had
Yes.
it.
No, that's square root. We're doing square root. Now, we're going to write this thing twice. Once with a minus, then again with the plus. These are the 2 factors. When you multiply those 2 things together, your answer is going to end up being 4x squared minus 25. So, we call this difference of squares. That's our step number 2. Only if we have 2 terms, though. All right, let's go on to the next one. We're still on 2 terms. This is the next page. Difference of cubes. Difference of cubes. Here we have a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. Those are the factors. Now this one's going to be a little trickier than difference of squares. A little bit more work involved on this one. Because this time instead of looking at difference of squares, now we're looking at difference of cubes. So it does make it a little more challenging. All right, so number 2. Example they give us is x cubed minus y cubed. First of all, there is no GCF, no greatest common factor. No greatest common factor. So what I need to do is I need to factor that out. What 2 things were multiplied together to get that answer? Well, first of all, the answer is going to be in this form right here. In other words, we're going to have a binomial times a trinomial. When I get done over here, I should have a binomial times a trinomial. So let's start with the binomial. Once I have the binomial, the rest is a piece of cake. So to get that binomial, to get the a minus b part, all they're telling us to do is we're going to take the cube root of each of these terms. Not the square root, but the cube root. So the cube root of x to the third is going to be x, and that's because an x times an x times an x will give you x to the third power. The cube root of y to the third is y, because y times y times y is y to the third power. Now notice that it is a minus sign inside that binomial. It's always going to be the same sign as what we have right here. That's why they call it difference of cubes. So there's our binomial. That's the first part. Right next to that binomial, we're going to put a trinomial. So how are we going to get that trinomial? Well, the trinomial, we're going to get it from the binomial. So there's three things I need. Three things that I need. To get the first thing, all we're going to do is take the first term, which for us is the x, and we're just going to square it. So what do you get if you take this x right here and you square it? You get x squared. All I did was take the first term, which was x, and I squared it. To get this middle part right here, what they want me to do is take the first and the second term of the binomial and multiply them together. In other words, the x times the y. X times y is xy. Notice that it is a plus though. These two signs right here will always be opposites of each other. Always, always, always. To get the last term over here, we're taking the last term of the binomial, which is our y, and we're going to square it. So if I take that y and I square it, I'm going to get a y squared. So these are my factors of x cubed minus y cubed. If I multiply those two things together, that right there is the answer I'm going to get. Piece of cake, all right? All right, we're going to stop right there, guys. We'll pick up with the sum of cubes tomorrow.
Wait, but why do you use x or y when you have a?